Have you ever gazed up at the night sky and wondered what lies beyond those twinkling stars? For centuries, humans have been captivated by the cosmos, but only in the last few decades have we begun to stretch our fingers into the vast expanse of space. And now, we stand at the threshold of humanity's most ambitious era of exploration. The missions planned for the next decade will fundamentally transform our understanding of our solar system and potentially answer one of humanity's most profound questions. Are we alone in the universe? The Red Planet has captured our imagination for centuries. From science fiction stories of Martian civilizations to the real possibility of human settlement, Mars represents humanity's first true step beyond Earth. But why is this rust-colored world so important to our future among the stars? Mars is more than just our planetary neighbor. It's our proving ground for becoming an interplanetary species. NASA's Perseverance rover has been analyzing Martian soil and atmosphere since 2021, preparing for the next bold chapter: human boots on Martian soil. The Artemis program, while focused on returning humans to the moon, serves as the critical stepping stone for eventual Mars missions. By 2030, NASA plans to launch its first crewed mission to Mars, a journey of approximately 7 months through the harsh radiation of interplanetary space. These pioneers will live and work on the Martian surface for approximately 500 days before returning home. Think about that for a moment. Humans living on another world for over a year, breathing manufactured oxygen, growing food in alien soil, and conducting experiments that could reveal whether life once existed or perhaps still exists on Mars. SpaceX's vision is even more ambitious. Elon Musk's Starship, the most powerful rocket ever built, isn't just designed for brief visits, but for establishing a permanent human presence on Mars. The company envisions sending hundreds of settlers over the coming decades, gradually building a self-sustaining colony that would forever change humanity's place in the cosmos. While Mars captures headlines, some of the most exciting missions target seemingly unlikely destinations: the moons of Jupiter and Saturn. Europa, Jupiter's ice-covered satellite, harbors a liquid water ocean beneath its frozen surface, containing more water than all of Earth's oceans combined. In 2024, NASA launched the Europa Clipper mission, which will arrive in 2030 to investigate whether this hidden ocean could support life. The spacecraft will conduct nearly 50 close flybys, coming within 16 miles of Europa's surface. Its instruments will measure the thickness of the ice shell, analyze the composition of material ejected through cracks in the surface, and map potential landing sites for future missions. Most tantalizing are the plumes of water vapor occasionally erupting from the surface. Natural samples of the ocean below thrust into space for our instruments to analyze. Even more intriguing is Enceladus, Saturn's small moon, where the Cassini mission discovered geysers erupting from its south pole. The European Space Agency's Enceladus Orbilander mission, planned for launch in 2030, will not only orbit this fascinating moon, but also land on its surface. The spacecraft will sample the plume material, drill through the relatively thin ice at the South Pole, and deploy a miniature submarine to explore the subsurface ocean. Imagine witnessing the first images transmitted from an alien ocean, perhaps revealing ecosystems completely independent of Earth's evolutionary history. Such a discovery would revolutionize our understanding of life itself. The James Webb Space Telescope has transformed our view of the cosmos since its deployment, revealing unprecedented details about distant galaxies, exoplanets, and the early universe. Building on this success, NASA and international partners are developing its successor, the Habitable Worlds Observatory. Set to launch in the mid-2030s, this next-generation space telescope will focus specifically on identifying and characterizing potentially habitable worlds around other stars. With a mirror nearly twice the size of Webb's and advanced coronagraph technology that can block the blinding light of parent stars, It will be capable of directly imaging Earth-like exoplanets and analyzing their atmospheres for biosignatures, chemical indicators of life. For the first time in human history, we may be able to determine if another Earth exists among the stars, perhaps with its own unique biosphere. The implications of such a discovery would be profound, forever changing our perception of our place in the universe. As part of the Artemis program, NASA and international partners are constructing the Lunar Gateway, a space station in orbit around the Moon that will serve as a staging point for lunar surface missions and eventually journeys to Mars and beyond. Unlike the International Space Station, which orbits just 250 miles above Earth, the Gateway will follow a highly elliptical path around the Moon, occasionally coming within 1,000 miles of the lunar surface and then swinging out to 43,000 miles away. This unique orbit, never before utilized by a crewed spacecraft, will enable efficient travel to and from Earth, access to the lunar surface, and provide a platform for deep space research. Construction begins in 2025 with the power and propulsion element and the habitation and logistics outpost modules. By 2028, the Gateway will support its first crew, marking humanity's return to lunar orbit after more than 50 years. The Gateway represents a fundamental shift in our approach to space exploration. Rather than brief visits, it establishes a permanent human presence beyond Earth orbit, a true outpost at the threshold of deep space. While most missions target destinations within our solar system, one ambitious project aims for the stars themselves. Breakthrough Starshot, funded by billionaire Yuri Milner and supported by a team of renowned scientists, aims to send a fleet of miniature spacecraft to our nearest stellar neighbor, Alpha Centauri. These spacecraft, each weighing only a few grams, would be accelerated to 20% of the speed of light using ground-based laser arrays. At this tremendous velocity, they could reach Alpha Centauri in about 20 years, compared to the tens of thousands of years required by conventional spacecraft. Each tiny probe would carry cameras and scientific instruments to study the Alpha Centauri system, including its potentially habitable planet, Proxima Centauri b. The data would take 4 years to return to Earth at the speed of light. While the technology requires significant development, prototype chipset demonstrations are planned for later this decade. If successful, these would be the first human-made objects to travel beyond our solar system with the specific intent of studying another star. These ambitious missions face significant challenges. Radiation exposure remains a major concern for human missions beyond Earth's protective magnetosphere. NASA is developing advanced shielding and medical countermeasures, but long-duration spaceflight will still pose health risks. The psychological effects of extended isolation in the harsh environment of space present another hurdle. Mission planners are implementing innovative crew selection processes and support systems to maintain mental well-being during years-long missions. Energy production in deep space, far from the sun, requires new approaches. Advanced nuclear fission reactors, designed specifically for space applications, are under development to provide the power needed for human outposts on Mars and beyond. Perhaps most challenging is the immense cost of these endeavors. International collaboration and public-private partnerships are becoming essential to fund and execute missions of this scale, distributing both the financial burden and the benefits of exploration. We stand at a pivotal moment in human history, the threshold of becoming a multi-planetary species. The missions planned for the coming decades will fundamentally transform our relationship with the cosmos and potentially answer questions that have captivated human imagination for millennia. From the dusty plains of Mars to the ice-covered oceans of Europa, from the distant exoplanets revealed by next-generation telescopes to the far-flung stars targeted by our first interstellar probes, each mission extends humanity's reach and expands our understanding of our place in the universe. As we gaze up at the night sky today, Those distant points of light are no longer unreachable destinations, but future homes, laboratories, and gateways to discovery. The journey will be challenging, requiring the best of human ingenuity, cooperation, and determination. But the rewards will reshape our civilization and our understanding of what it means to be human. What role will you play in humanity's cosmic journey? How will the discoveries of the coming decades change your perception of our place in the universe? Share your thoughts in the comments below, and subscribe to stay informed about humanity's next giant leaps into the cosmos.